Alright, hello everybody. Today we are going to be going over this problem. This one's called the Dutch national flag problem. So let's take a look at what the problem is asking. Given some balls of three colors arranged in a line, rearrange them such that all the red balls go first, then green, and then blue ones. Do rearrange the balls in place. A solution that simply counts colors and overwrites the array is not the one we are looking for. This is an important problem in search algorithms theory proposed by Dutch computer scientist Edsger Dijkstra. Sorry if I'm pronouncing the name wrong. Dutch national flags has three colors, albeit different ones used in this problem. So right now we have green, blue, red colors, but the way we want them outputted is all the red colors being put in first, then the green ones, then the blue ones. There are a total of 2 red, 4 green, and 2 blue balls. Alright, so there are multiple ways we can approach this problem. One way that immediately you can come to mind is just loop through the array, go one by one, see a red one, and if it's a red one, put it at the beginning, keep going, find another red one, put it on the second beginning, and then you'd have to loop through multiple times to do that, first for the red ones, and then the green ones, and then the blue ones. The problem with that way is that it would be very time complex in like a larger array with tons of elements. So we want to find a solution in which we can do this all in one go. So like we just have to go from left to right and immediately place each element and swap it in the correct order. So the way we would do this is by using a pointer method. So let's start by setting up 3 pointers. Well, first let's start by defining the function. Define Dutch underscore flag underscore sort balls. So we're gonna have that array. Next up, we're going to do it using a 3-pointer approach. So we're gonna have one pointer that keeps track of red ones, one pointer that keeps track of green balls, and one pointer that keeps track of blue balls. So how we're gonna set this up is we're gonna set 3 variables I, j, k. Sorry about that. We're gonna set I to 0. We're gonna have I start at the first index, j start at the first index as well, but we're gonna have k start at the last index. And to get the last index, all we need to do is type length of balls minus 1. So you can visualize 3 pointers here, here, and then here. So there's going to be 2 pointers on the first element and 1 pointer on the last element. So what's going to be our condition to loop through this array? We're going to continuously loop through this array while j is greater than or equal to k. So what this means is that we're going to continue looping through these looping through the array, but we're going to stop when we see that the middle element, the middle pointer we have, j, becomes more than the last pointer element. And the reason we would want to do that is because j is keeping track of the greens, right? Well, not necessarily the greens in this case, in all cases, as we'll get to, but once we see that the j has surpassed the k, which is the marker that we have on the right side, we know that basically everything should be at this point already in place. So we're going to loop through this array starting with the j pointer, the k pointer. Sorry, j pointer. I don't know why I said k. Okay. If balls of j, we're going to say if that one is equal to R. So what this means is if the middle pointer is the red one, all we're gonna do simply is we're gonna swap this one with the first one. So we're gonna swap the pointer at J and the pointer at I, because we know that if the middle pointer is green, we want the left pointer to be red and swap with the middle one. So how we can do that quickly in Python is by saying balls of I comma balls of J is equal to balls of J comma balls of I. So this is a way, a quick and easy way in Python to swap. It basically creates a temporary variable so that we can swap whatever value is at index I and index J. So we swap these two values. And once we know that we can swap them, all we need to do is increment both of them. Because, yeah. We can already see this as the first example. Like, for example, in this array, well, this is the sorted array. But for example, yeah, if in this array, for example, there won't be any swapping taking place, because there will be swapping place. It'll just be swapping these two, and then we'll increment continuously these two, and then this one. At this point, we are going to be doing something else. So now, if the balls is not R, the middle pointer, if it's not R, but rather else if balls of J is equal to G, if the middle pointer is green, then that's all fine and good, because we want the middle pointer to be pointing to a green value. So in that case, all we need to do is just increment it by 1, since we know, yeah, nothing is wrong once the middle pointer is G. And now the final one, balls of J is equal to K. We could do this, not K, B. We could do this, or more likely it's probably simpler to just use an else element, because we already know that there's only going to be R, G, and B in the array we input, so we could just use else. Else, we're just going to be swapping. If the element that the middle pointer is on is blue, then instead of swapping with the first element, the I element, we'd swap with the K element. Else balls of J, sorry, comma balls of K is equal to balls of K, comma balls of J. And then in this case, instead of previously we would increment both I and K, but in this case, since we're continuously appending the green anyways when we're moving green up, there's no point in doing that for this one. So all we need to do is decrement K. K minus equal 1. Sorry, I don't know why I put K here. I meant to put J here. And also, why did I put K here? I'm mixing up some of the elements for some reason. So when we're incrementing balls of I, balls of J, all we need to do sorry, for some reason there's an error here. Oh, there's no reason for me to put this up. Okay. So this is how the final result will look like. Basically, we're continuously setting this pointer. We're making sure that the pointer is always hold on. K is greater than or equal to J. This is my bad. So if you guys were following along, some of this might have been obvious in the beginning, and you might have commented or something. Comment if you catch where my mistake was. But you always need to make sure that the k, which is the last pointer, is greater than or equal to the j, which is the middle pointer. And then we're going to be in the first condition, if the middle pointer is on the red value, we'd swap it with the first value, increment the first pointer and the second pointer. If it's green, you just need to increment the middle pointer. Otherwise, you swap the middle pointer and the last pointer and decrement the last pointer. And by the end of this, all we need to do is return the array, and hopefully it's going to be sorted in the way that we want. So now it's time to just simply test the code. Print Dutch flag of sort balls, but we didn't define balls yet. So let's just try the first example. If balls looks like this, what we should be expecting is going to be the first R value, like over here, the R's are in the beginning, greens are in the middle, and then blues are at the end. So let's run this code, see how it works. And here we go. You see that the R's are in here, then there's going to be the greens, and then finally the blues. We could test this. Let me look up some other test cases from the sidebar I have here. How much more time do I have? I have 2 more minutes. Okay, let's we could test an edge case, for example. If it's just one value, it doesn't mess anything up. Yeah, it'll just be R. How about this? This is a big one. There are a lot of big test cases that I can use that would be kind of a pain to copy paste. Let's see if I can do this though. Oop. So we got a full length one over here. I could try running to see if this works, but my IDE is kind of suffering right now. But yeah, we could see that it kind of works actually when we run the code. Looks like all the blues are in the bottom, but we can't scroll all the way to the top. But essentially, you got the idea with the first test case that this code essentially works the way it's supposed to. It's getting all the reds in the beginning, greens in the middle, and blues at the end. So it can work with, it is also pretty time complex. It can work in basically n time complexity, since we're only doing one while loop, as we can see here. So hopefully you guys understood the solution well, and I'll see you guys in the next time. Alright.